Okay, hi, my name is Chen. So today I'm going to talk about ocean erosion stabilization. So for the online, I'll be covering introduction, project design objectives, ocean erosion, study analysis, design, environmental impact, and conclusion. So for the introduction, the city I chose is Manhattan City, California. So the channel bottom along Manhattan is stretching out through Hermosa Beach all the way to Long Beach. So it is a major problem to the area residents. So the adjacent properties, homes, parking lots, and drives are under the threat of sea erosion. So this project I designed is intended to propose an erosion stabilization mechanism which is cost effective and with the ability to keep the property free from the erosion threats. So project objectives. So the objective of this design is to eliminate the ocean and shore erosion as well as the delivery of sediments into the ocean. So the erosion prevention design will also facilitate a reduction of a potential threat to adjacent property damage while maintaining the bionetwork of the ocean. So basically, what is ocean erosion? So ocean erosion is the coastal and shore erosion primarily caused by the water waves driven by winds. So duration and the velocity of the winds as well as the stretch of the ocean that the wind blows are the dominant features that generates the attacking waves possible for erosion and attack of the shoreline. So the height and the strength of the wave are stronger in coastlines. Study analysis. So Manhattan Beach is one of the beachfront city situated on the southwestern side of Los Angeles, California County. So the beach coast is characterized by high water wave that may exceed 12 feet during the winter session. That's weak, creating a threat to the residents as the wave induce the erosion. So the picture on the right shows the coastline of the Manhattan Beach all the way to the Hermosa Beach. So right now I'm going to talk about the slope and the wave analysis. The beach line along the Manhattan Beach experiences rising wave up to 15 meters high, thus facilitates the beach erosion and sweeping the sediments into the sea. So the picture on the right shows the wave height throughout the timeline historically. So what we can see is that in 2012 the Hurricane Sandy makes the water level hits the peak of 17.5 feet. So the design I chose is to use the the sand wall or the rock wall to be 14 feet high. And for the design, we have to consider about several factors, which when we're selecting appropriate strategy to be used in the stabilization of the seashore erosion. Some of the factors, including cost, environmental aspects, the rate of erosion, and legal permits. So for the cost of erosion stabilization vary from the approach of erosion control selected and the contractor used for the job. Also the cost of implementation, but we have to consider both non-structural and structural by the construction detail. And the environmental impact. So the majority of the aquatic habitats, cover, and food species of marine organisms and fishes are found in the tidal zones. So in this area we have to build up the erosion stabilization away from this area, because the buckets are thread using chemicals which dissolves in the water, so it'll be poisoning and toxic. So the marine organism needs to be preserved, as well as other tourism activities that requires in contaminated water. So for the conclusion, the coastline of California from Manhattan stretching Long Beach is relatively flat. Thus, the extent of erosion is not that severe. So the approach of the design is suitable, as it's cost saving and encourage the protection of adjacent properties from erosion. So thank you so much. That is my presentation of the project.